Hello, students. Our lesson today is on Unit 6, Lessons 8 and 9, Key Features of Square and Cube Root Functions. And the benchmark that we're looking at is MA 912 AR 7.2. Given a table, equation, or written description of a square root or cube root function, graph that function and determine its key features. Our learning targets: I can graph a square and cube root function given a table or a function. I can determine key features of a square and cube root function. Excuse me. Here's some vocabulary to think about. First, we're going to look at relative maximum. A relative maximum is the y value of the point where the function changes direction from increasing to decreasing, or the y value of an endpoint where the function is always decreasing. That's relative maximum. For relative minimum, a relative minimum is the y value of the point where the function changes direction from decreasing to increasing, or the y value of an endpoint where the function is always increasing. So does square root functions and cube root functions such as g of x equals the square root of x and the cube root of x have a relative maximum or minimum value? Think about that question. So here you can see on both graphs, the first one to the left, g of x equals the square root of x, and g of x equals the cube root of x, they both have a relative minimum, and that's where it's at 0, 0. Let's move this out the way. So let's look at some guided instruction. Here's an example that we can determine the maximum, the minimum, and some key features. We're going to graph this function. G of x equals 2 times the square root of x plus 4 minus 1. So let's use the equation and the table of values to graph x. So given the table of values, let's see if we can get a pen going here. And it's to plot the points. So we need to start, let's look at the first point, -4, -1. So we start from the center of the graph, 0, 0, and we're moving to the left 4 places, 1, 2, 3, 4. Don't place your point there because we have to go down 1 based on the point. So right here would be -4, -1. Okay, the next point we have -3, +1, 1, 2, 3, and up 1. Place that point there. 0, 3, so at 0, and then we go up 3, 1, 2, 3. Here's my point here. And then 5, 5. So from the center, 5 to the right. 1, 2, 3, 4, 5, and up 5. 1, 2, 3, 4, 5. My points aren't exact, but they should be clear enough for you to see. So the points are plotted. Let's connect those best as you can. All right, so we just graphed using that table of values. So this is what it should look like. The points on the graph, This one wasn't highlighted so well, but here is also a point. And 5, 5 is here, so also here a point. All right, so let's look at some key features. Our domain, -4, comma, positive infinity. So the -4 is included up to positive infinity. So that simply means x is greater than or equal to -4. That's our domain. That's on the x-axis. For our range, it goes from -1 to positive infinity. So here, for our range, it's y is greater than or equal to -1. So if you look at the graph, you will see that as well. Our x-intercept, it actually works out to -15/4, comma 0. The y-intercept, which is what we graphed, let's go back, looking at here, this is the y-intercept on the y-axis. It's at 0, 3. That's this point right here. That's our y-intercept. The interval where the function is increasing, that's where our domain is, -4 to positive infinity. There's no interval where the function is decreasing. So if you go back and look at the graph, you will see that our points, when we connected them, it's an increasing graph. The interval where the function is positive, that's where it starts at our x-intercept, -15/4, and it goes to positive infinity. The interval where the function is negative, it starts at -4 and it goes to -15/4. The relative maximum or relative minimum, it's at -1. That's the relative minimum. And our end behavior, as x goes to positive infinity, g of x also goes to positive infinity, increasing. And as x goes to -4, g of x approaches -1. So these are the key features for this example. G of x equals 2 times the square root of x plus 4, all of that minus 1. Let's look at another example. This example is about cube functions, cube root functions. So let's consider the function p of x, 2 times the cube root of x plus 1 minus 3. So first, we should complete this table of values for p of x, and then we're going to graph the function on the coordinate grid. So to complete this table using the x values, we're substituting or replacing the x in the equation with -2. Let's start with -2. So we enter -2 plus 1, that gives us -1. And the cube root of -1, it's -1. And -1 times 2 gives us -2. -2 minus 3, this should be a -5. Excuse me. So we'll do the same process with the remaining x values. And in doing so, this is what your graph will look like after getting all the points to complete that table. -1, -3, -1, -3 would be right here. -2, -5 would be right here. 0, -1 would be here. And then positive 2.375 is about here, comma 0. And then 7, positive 1 would be here. And as you see, the points connected gives us a shape. And this time it did not go through the origin. Now let's look at our key features for this example. So not all key features may be applicable for the function. So for this example, our domain, it's -infinity to +infinity. And it will be the same for our range. So the domain is our x values, and the range would be our y values. So based on the graph itself, our x-intercept, it's 19/8, 0. Our y-intercept, that's on the y-axis, 0, -1, that's where it touches the y-axis. Our interval for the function is increasing, -infinity to +infinity. There's no function or interval where it's decreasing. And then the interval where the function is positive, 19/8, infinity, +infinity. And the interval where the function is negative, it's -infinity, 19/8. Our end behavior, as x approaches infinity, f of x approaches +infinity, or that should be p of x. And as x approaches -infinity, p of x approaches -infinity. What are your key features for the cube root function? Thank you so much for watching. I hope you were able to follow along and get a better understanding of square root functions and cube functions and their key features. Have a good day.